Hello, I'm Mr. Howard. In this video, we're going to do a review of solving linear systems. We're going to do that algebraically. This is for my pre-cal students at the beginning of the year doing an algebra review. I do have videos on the YouTube channel where I use a calculator to solve systems, one using the matrix method and one using the graph intersection method. So if you're looking for calculator help, watch those videos, but in this video it's just a review, so we're only going to work 4 examples and we're going to use the 2 algebraic methods of substitution and elimination. Okay, so remember that when we find the intersection of, let me back up. When we're finding a solution to a system of equations, we are just finding the intersection point of 2 lines. That is what the answer to a system of equations is. Okay, where the 2 lines cross. That's essentially all we're doing. Okay, this is a very useful mathematical tool, because when you're trying to find where, for example, you've got a situation where you're at a job where you have 2 models of data that are represented by linear equations, and you want to find where those 2 things are equal. Maybe that's like a break-even point or something like that for whatever you're looking at. That intersection point is very important, because that's where the 2 are equal, and maybe one line or one model of data is better for you at some point, and that intersection point is where it changes, where one, because if you're looking at 2 lines, for example, like this, and let's say your y-axis is profit, for example, well, this key point where they intersect is very important, because your profit is better with this model here and your profit is better with this model here. Okay, so that intersection point, that's where things change. So intersection points are very important. Alright, and they're used all the time, because that's where you can tell where one setup is better than the other. Okay, so anyway, that's just a little background on how they're used. Let's look at this example 1. In the first example, we're going to use elimination. So with elimination, the goal is we have x plus y equals -1 and 3x minus 2y equals 1. The goal is to either make the y terms cancel out, therefore we eliminate them, so we just solve for x in that case, and then we in turn sub back in and solve for y, or we make the x terms equal to one another and therefore eliminate them, so we are just solving for y at that point. So in this case, I'm going to write the 2 lines, x plus y equals -1 and 3x minus 2y equals 11. Okay, so we have multiple options here. You could multiply, remember the coefficient in front of the x or y term would need to be the same, but the sign would need to be opposite in order to cancel them out. Okay, so in this case, I'm just going to multiply. The first thing that jumps out at me is to multiply this equation right here by 2. Multiply all terms by 2. That'll give me a 2y here, which will then cancel with this. Okay, so I'm going to multiply this whole thing by a 2. Okay, so that's going to give me 2x plus 2y equals -2. Alright, so then I'm going to now just eliminate the y's here. So I have 3x and 2x would then give me a total of 5x. I'm adding here, by the way. I'm adding, so that gives me 5x. -2 plus 2 gives me nothing, right? So that those y's cancel out, which is what I wanted. And then 11 plus -2 gives me 9. So that means my divide by 5 here, and that means x equals 9/5. Okay, so I'm almost done. So now I take this 9/5 and I plug it back into either one of these equations. Which one? I'll just plug it back into the first one. So I'm going to substitute this 9/5 in right there. So that would give me 9/5 for my x plus y equals negative 1. So I'm going to subtract 9/5 from both sides. Subtract 9/5 from both sides, and that gives me y equals. Okay, we're working with fractions here, so I'm just going to rewrite 1 as, instead of negative 1, I need to put it over 5. So that would be negative 5 over 5. Okay, so negative 5 over 5 minus 9 over 5. Okay, that's all I did. I just changed negative 1 into negative 5 over 5. Negative 5 over 5 is still equivalent to negative 1, but now I can work with the fraction. So negative 5 minus 9 gives me negative 14 over 5. So my y is equal to negative 14 over 5, and I have solved the system because these two lines right here cross at the point 9/5, comma, negative 14/5. Okay, and I could check that with a calculator if I wanted to. Alright, so let's go on to example 2 here quickly. Okay, example 2 here. So with this example, we're going to use substitution. We used elimination before. This time we're going to use substitution. Both methods work, but you need to know how to use both methods. And once you get good at using both methods, you can look at the two equations that you're solving a system for and pick the method based on how the equations are formatted. So this one we want to use, again, substitution. So when I see these two equations, I immediately start looking at this first one right here because the coefficients are equal to 1 in front of x and in front of y, and that just makes it easier to solve for one, because with substitution our first goal is to solve for either y or solve for x in one of the equations and then substitute that back in to the second equation. That's the process. So with this one, I'm just going to take this equation, x plus y equals negative 1, and I'm going to go ahead and solve for y here. I could solve for x, but I'm choosing to solve for y. So y is just equal to subtract x from both sides, negative x minus 1. Okay, so now I've solved for y, and now I take this value of y right here, and I'm going to substitute that in right there for that y. That way, I rewrite the second equation, 3x minus 2 times this chunk right here now equals y. So negative x minus 1 equals 11. So now I have this whole thing written in terms of x only. I only have one variable which I can solve for. So I just need to distribute. So I get 3x, then negative 2 times negative x is plus 2x. Negative 2 times negative 1 is plus 2, and that equals 11. Combine my like terms, I get 5x, and I'm going to subtract 2 from both sides and get 11 minus 2 is 9. So 5x equals 9. So divide by 5 on both sides, and I get x equals 9/5. Okay, so part of it's done. X equals 9/5. Now I'm going to take this 9/5 and I'm going to substitute it back into one of the equations. Again, I have a choice here. I can sub it back into either equation, substitute it back into either equation. But I'm going to pick the one that I think is easiest, which is the top one, because the coefficient of x is just 1, so it makes it a lot easier. So I'm going to take this 9/5 and I'm substituting it back in right there. So I'm going to rewrite this equation, substituting 9/5 in for x. So I get 9/5 plus y equals negative 1. So I'm subtracting 9/5. I get y equals negative 1 minus 9/5. Okay, we've got fractions here. The easiest thing to do is rewrite negative 1 as something over 5. So it makes it pretty easy. So y equals negative 5 over 5. Notice negative 5 over 5 is still equal to negative 1. But now I have common denominators here, so I can just work with these fractions. So I get y equals negative 5 minus 9 is negative 14 over 5. That's a 4 there. Negative 14 over 5. So there is my y-coordinate of the intersection of these two lines. So the solution to my system of equations here is 9/5, comma, negative 14/5. Final answer right here. This ordered pair is the intersection of the two lines that I was given. Alright, so 9/5, comma, negative 14/5. Alright, let's move to the next example. Alright, example 3 here. I'm looking at these two lines. 4x minus y equals negative 2, 12x minus 3y equals 5. And I need to solve this system. So find where these two lines intersect. That's my goal. So looking at this, I'm going to choose to use elimination here. So I'm going to take this line, 4x minus y equals negative 2, and I'll eliminate the y terms. So I have a negative 3y in my other line, so I need a positive 3y here. So how can I make negative y equal positive 3y? Well, I need to multiply everything by negative 3. So I'm going to multiply everything on both sides times negative 3. So that gives me, distribute in here, and I get negative 12x plus 3y equals negative 2 times negative 3 is positive 6. So this is equivalent to this right here. So now I'm going to just add the two lines. So I'm going to bring this line, my second line, down here. So that's 12x. I'm adding these two here. And negative 3y. This is just line 2. This line right here. This line right here. I'm rewriting. And that equals 5. Okay, I'm adding all of this. So negative 12x plus 12x, those cancel. 3y plus negative 3y, those cancel. So I get 0 equals 6 plus 5 is 11. Okay, so here is a special case. I have 0 equals 11. Is that true? And the answer is no, it is not true. Therefore, this system has no solution. No solution. Okay, if you have a special case, if you are working with the two equations and your variables, your x and your y, both cancel out and you're left with constant equals constant, you have a special case. It's either no solution, which occurs if your whole number or constant equals constant is not true, it's no solution. If the constant equals constant that you end with is true, so they're the same on both sides, then you have infinite solutions. So in this case, it's not true, so we have no solution. So what does that mean about these two lines? Well, that means these two lines are parallel. They have the same slope. They will never intersect. Okay? Alright, so the answer here would be no solution. Let's move on to the last example, and we'll be done with this video. Alright, example 4, last example. We need to solve the system of equations here. We've got these two lines. I'm going to, in this case, use substitution. This makes it pretty easy here because they already gave me y equals 2x minus 5. So I already know what y is equal to. So I can just substitute this chunk right here in for that y and solve this equation for x. And that'll basically accomplish what I need to do. So let's do that. So I'm going to rewrite this equation right here. This equation right here as negative 6x plus 3 times the quantity, and remember I'm substituting 2x minus 5 in for y here, so 2x minus 5 equals negative 15. So now I'll just distribute here, so I get negative 6x plus 6x, 3 times 2x is 6x, and then 3 times negative 5 is negative 15. That equals negative 15. So negative 6x plus 6x, those cancel. So I have negative 15 equals negative 15. So I have a special case again. My variables are gone. So I have negative 15 equals negative 15. If that is false, it's no solution. If it's true, it's infinite solutions. It is true. So that means it is infinite solutions to this system. Infinite solutions. Okay, and what that means is this line, y equals 2x minus 5, and this line, negative 6x plus 3y equals negative 15, is the exact same line. So they are literally stacked on top of each other. Okay, so that's where the infinite solutions comes from. They are the exact same line. Alright, so that is a wrap for this video. That's 4 examples. We did substitution, we did elimination, and we covered the 2 special cases where you have either no solution or infinite solutions. I'll see you in the next video.